All right, we're going to be adding and subtracting rational expressions. And really the method used to add and subtract numerical fractions, like 3/8 plus 5/6, is the same we use when we're adding and subtracting rational expressions. So find a common denominator. And I'm going to show you how I'm going to stack these other problems in order to do this. So, oops, it's just a nice organizational strategy here. So I'm going to take 3/8, and I'm going to add to it 5/6. All right, and you're going to see a big, long summation bar there. And what I want to know is I need to multiply the 8 by something or the 6 by something to get a common denominator. And I know that 8 and 6 both go into 24. So I want to multiply 8 by something to get 24 and 6 by something to get 24. I realize you can do this in your head, but I'm just showing you how I'm going to do this on these other problems. So 6 times what is 24? Well, that's 4. Okay, and so I'm multiplying by 4 over 4 because really when I multiply 5/6 by 4 over 4, I'm really multiplying 5/6 by 1. So I'm not changing its value, I'm just changing its form. 6 times 4 is 24, 5 times 4 is 20. Okay, it's 5/6 and 24 are proportional, they're the same value. 8 times what is 24? That's 3. 3 times, well, that has to be 3 because that's 1, right? You have to multiply by something over itself. 3 times 3 is 9. So what does that give me? Well, 9 plus 20 is 29 over 24. Okay, numerator over denominator. Okay, and remember, you just keep the same common denominator and add the numerators. Well, this 24 is called your least common denominator. Now, this textbook and most textbooks like you to go through the process of finding a least common denominator before you add these. In fact, it's a whole nother problem set. I don't do that. I just do it in context of the problem. Okay? And that's only if you need a least common denominator, right? I mean, for instance, on these first ones, adding and subtracting with a like denominator, well, in this case, they both are 6x. Then just add your numerators. It's just 7 plus 5 on top. And 7 plus 5 we know as 12. So that's 12 over 6x. Now at the end you should always try to reduce. And since you're multiplying 6 by x, you can reduce the 12 and the 6, right? 6 goes into 12 twice. And it goes into itself once. So you get 2 over x. All right. Okay. Let's try this other one here. X minus 5 and x minus 5, denominators are the same. So we'll keep that, x minus 5. And we'll subtract the numerators. Now, I don't like to subtract, I like to add the opposite. Okay, so another way to think about it is that you just take this negative sign and move it up to the numerator up here and make that plus. You'll see why in a while. It makes it a little easier. So I have 3x minus 5 on top. The question is, can I cancel out these 5? And the answer is no, because on the bottom there are implied parentheses. And in fact, on the top, in the numerator, there's implied parentheses. Meaning you have to do the math there before you can cancel. Okay. Now over here, it didn't matter because you're multiplying. When you're multiplying on the bottom, it's not going to change because your multiplication and division, which you're doing when you're canceling, is division. They're the same process. They happen, multiplying and dividing when you're multiplying, or excuse me, when you're dividing, you're actually multiplying by something less than 1, or in between 0 and 1. So it doesn't matter the order. Whereas here, you have subtraction. And the order does matter. You have to do the subtraction before you can do the division. It's kind of reverse order there. Like they're implied parentheses. So you have to do all the math on the top and bottom before you can cancel if you have addition and subtraction signs. Okay, so that is my solution. Cannot cancel those 5. Okay, well, if you have unlike denominators, we need to find the least common denominator, which is found by finding the least common multiple. And like I said, the textbook likes to always have you go through through the process of doing the math here and finding the denominator or least common multiple of this and this, and kind of in their separate problems. I like to just show you this in context of this problem. So if I have 7 over 4x squared, And I am adding x over 12x squared plus 8x. I should have told you not to copy that yet. Okay? Well, this is a really cumbersome problem. I mean, the math behind there's just tons of numbers here. If you can reduce in any way, you should definitely try it, right? So really the rules that you should do first, the first thing you should always try to do is, number one, I keep zooming in. Number one is factor. Factor your numerator and denominator. So when I look at this, and I'm going to erase right here. I know that just got rid of all my hard work. So if I'm looking at this, 4x squared is already factored. You can't change anything. It's multiplying already. However, there's an addition sign here. And can you factor out anything from 12x squared and 8x? And the answer is yes. You can take out a 4x. Well, 4x times what is 12x? 4 times 3 is 12. X times x is x squared. So 4x times 3x is 12x squared. 4 times what is 8? Well, that's 2. And we already have the x. So 4x times 2 is 8x. You've now factored that. And the next thing you want to try to do is reduce the fraction. Yeah, well, can I reduce here? Is there anything that goes into 7 and 4 other than 1? No. And there's no x up here. Can I reduce here? Here's an x. Is there an x down here? Well, yeah, right here. Okay, so I can cancel out those x's. Now, some of you might go, well, hold on. What about that whole thing you just talked about the adding and subtracting? Well, these parentheses are multiplying by that x. So whatever's in here doesn't really matter unless you're trying to cancel out a 3x plus 2. You'd have to cancel that, take this whole piece together if you're trying to cancel that. But here I'm just canceling x's, so I'm good. So really my new problem is 7 over 4x squared plus, well, this is now a 1 up here, 1 over 4 times 3x plus 2. That looks a little prettier than what we had. Still looks pretty messy. But you're going to multiply by something to get a common denominator. And that whole process we did right back here, up here. That's why I showed this. Okay? So you need to ask yourself, all right, looking at your factors, my factors up here are 4x and x. I say x and x because there's an x squared. And down here I have a 4 and I have a 3x plus 2. 3x plus 2 is all one factor because it's held together with parentheses. You got to say, what factors do I have up here that I don't have down here? Well, the answer is I have a 4 up here and I have a 4 down here. I have an x squared and, well, I don't have an x squared down here, so I need an x squared. Okay? And then that's it. And then you have to say, well, what factors do you have down here that you don't have up here? Well, I have a 4 up here that it's down there, but I don't have this 3x plus 2, so I need this 3x plus 2. Okay? Well, you'll notice now when you multiply across in your denominator, 4x squared times 3x plus 2 is 4x squared, 3x plus 2. And 4 times x squared times 3x plus 2 is 4 times x squared times 3x plus 2. You now have a common denominator. Now there's other ways to find that common denominator, or least common multiple. Like textbooks may say, we'll just multiply the two denominators and reduce. I think it becomes really complex that way. I go through this process. So remember, x squared, you have to multiply by x squared over x squared because that's equal to 1. So whatever you did to the bottom, you have to do to the top. The 1 times x squared is x squared. And this has to be 3x plus 2. And really, you have now 7 times the quantity 3x plus 2. Now, I would usually, as I'm bringing it over, I would usually just say 7 times 3x is 21x. And 7 times 2 is 14. I usually wouldn't show that, but I showed it because I'm teaching it here. Okay? And now you add straight down. Common denominator, 4x squared times 3x plus 2. and 21x plus 14 and x squared, so I'm going to put the x squared first. 21x and 14. At the very end, you should always try to factor and reduce. Well, there are 14, two things to multiply to make 14 and add to 21. There are none, so you can't factor the top, so that means you are done. You don't have to multiply out the bottom if you don't want to. You definitely could, but you don't have to. All right, well, there's the first problem. I just like the organization there, it helps out. Let's try this next one. All right, so let's factor first. X is already factored, x minus 3 is already factored. You could take a negative out here if you want. That's always a good strategy. So negative, if a is negative, so negative and then x plus 2. Okay, so negative times x is negative x, and negative times 2 is negative 2. And here I can take out an x, and that would give me x squared minus x minus 6. And then I can factor this whole thing. This actually becomes x times x minus 3 and x plus 2. All right. And can't reduce. Oh, yeah, I can. Can reduce right there. I could take out an x plus 2. Now I just have a negative 1. So now I have x over x minus 3. And we're adding that to negative 1 over x times x minus 3. So we need to know what you're multiplying by. That's going to equal. Well, looks like I have an x minus 3 up here, but I need the x. And I have an x and an x minus 3 down here, so I don't need anything. So x times x minus 3, x times x minus 3, negative 1, x times x is x squared. We add down, we get x squared. Holy moly, x squared minus 1 over x times x minus 3. You should always try to factor the top if you can, and this is difference of two squares. So I get x plus 1 and x minus 1 over x times x minus 3. And it doesn't look like anything works out there. Nothing you can factor. So I think we are done there. Okay, well, let's go ahead and move on to the next one there. All right, find the sum or difference. So we have the 2 over 3x squared plus 12x and 8 over 2x. So let's start. Remember, we'll go factor first and then reduce if we can. Okay, so factor 3x squared and 12x. Well, it looks like 3x goes into both of those. 3x times what is 3x squared? That's x. 3x times what is 12x? That is 4. Okay, so we get 3x plus 4. And then here, can't factor 8 over 2x. However, you can do some reducing, right? This is going to become 4. 2 goes into 8. 4 times 2 goes into 2 once. And actually here, to try to reduce, I can't take anything out of 2 and 3 or 2 and x plus 4. Can't do anything there. However, I'm going to take and make this an addition and move that negative up here with the 4. So when I write this now, I have the fraction 2 over 3x times x plus 4. And I am adding it to negative 4 over, well, just x. So what am I multiplying by to get a common denominator? And what is that common denominator is the question. Well, it looks like here I have a 3, I have an x, and I have an x plus 4 as factors. Here I just have an x. So down here I need a 3 and an x plus 4. I've already got the x from up here. And 3x and x plus 4, well, I don't need anything up here, so I'm just going to multiply by 1. So I get 2 over 3x and x plus 4. And x times 3, 3x and x plus 4. And 3 and x plus 4. So I end up with negative 12 and x plus 4. And then we add down, right? Well, I'm going to go ahead and multiply this out. Like I said, I usually wouldn't show that, but as I'm teaching it, I'm going to. So that's going to be negative 12x plus 48. Okay. And so, excuse me, minus 48. Okay, so I have negative 12x, and I have minus 2 and negative 48 is 46. All over 3x times x plus 4. Now, like I said, you should really factor if you can, right? Factor and see if there's anything that will go into both. Well, in this case, we have negative 12 and 46 there. And when I look at it, I mean, 2 goes into it, but you're not going to be able to take a 2 out of the bottom. So if you wanted to, you could call it, maybe take out a negative 2 and you get 6x minus 23. Okay. However, that's not going to help you much with the x plus 4 there and 3x on the bottom. You can't cancel anything. So that is, either one of these are your solution. Right. Well, I think I have one more problem like this here. Okay, let's do this one. So, start by factoring. On the top, looks like I take out a 2. And on the bottom, it looks like I take out a 4. And looks like right here with the 2x minus 10, I can take out a 2. Okay, and I can take out a negative 1 right here. And anytime you have an a term that's negative, try to take out a negative 1. All right, and let's go another round of factoring if we can. All right, we'll say x squared plus x minus 2, so it looks like 2 times x plus 2 and x minus 1. Okay, and here we get 4 times, well, 2 things that multiply to make negative 15 and add to negative 2. That's going to be x minus 5 and x plus 3. Okay, and I forgot a parenthesis right there. We'll add that in, but I can't do anything. It looks like that's it. Okay, and so looking at some reducing, 4 and 2, looks like I can do some reducing there. So we'll make this 4 goes in, or 2 goes into 4 twice, 2 goes into 2 once. Here doesn't look like I can reduce anything. However, I'm going to change this minus, excuse me there, this minus to a plus, and move the negative up here, which makes that a positive now. Okay. So I've done a lot of factoring there. So hopefully you're good at factoring. So a new piece, I have x plus 2 over x minus 1 over 2 times x minus 5 and x plus 3. Plus, looks like x plus 1 is here over 2 times x minus 5. When we write it like this, like I said, it just shows, a lot easier what we're multiplying by to get our common denominator. You can actually see that common denominator. So I have a 2 and x minus 5 and x plus 3, and I have a 2 and an x minus 5. So down here, I'm missing the x plus 3. On top, I'm not missing anything. Okay, I have all 3 parts that I need to get to x minus 5 and x plus 3. I have that there. and I have it here. So I am now pretty good there, and I have x plus 2 and x minus 1, and I have x plus 1 and x plus 3. All right. And, well, let's go ahead and multiply these out. So we'll change this. This is going to become x squared plus 4x plus 3. You multiply using FOIL. And this is going to become x squared plus x minus 2 if you multiply using FOIL. Okay. And so adding down, we have x squared and x squared is 2x squared. X and 4x is 5x. And negative 2 and 3 is 1. And our 2x minus 5 and x plus 3. Now, make that look like a 5. 2x squared plus 5x plus 1 does not factor. Two things I would have to multiply to make 2 and add the 5. Nothing. So you're now done. There we got it. All right, the only thing we have left are complex fractions, and that's a fraction that contains a fraction in both the numerator and denominator. And really what you need to do on these is simplify both the numerator and the denominator first, and then divide. So treat it like two different problems. Really, you have this problem up here that you need to do. Okay, so I have 1/5 minus 4/25. And I don't expect you to stack them like I do on that previous. I mean, hopefully you could just say, well, two things that multiply to make, or excuse me, what goes into 5 and 25? Well, let's switch that around. What do 5 and 25 both go into? Okay, well, 5 goes into 25, so they both go into 25. So the common denominator is 25. What did I multiply 5 by to get 25? Well, that would be 5. And 5 times 1 is 5. So 5/25 is the same thing of 1/5. They reduce. 5/25 reduces to 1/5. It's proportional. 5/25 minus 4/25, well, with a common denominator of 25, that is 5 minus 4, or 1/25. So really, I now have a fraction on the top of 1/25, and I am dividing it by 25/4. Now, if I rewrite this fraction, 1/25 divided by 25/24, as 1/25 divided by 25/4, right, using an actual division symbol. Well, we don't actually divide, right? We always multiply by the reciprocal of the back. So that would be 1/25 times 4/25. And then we multiply straight across. That's 4, and that's 625. Now sometimes it takes a while. You're like, adding, subtracting, and then you all of a sudden you go to multiplying. Don't have to have a common denominator, even though we do. Always try to reduce. Nothing that goes into 4 and 625, so you're done. Now it gets a little more complex, no pun intended. Okay, actually there was a pun intended, but that's okay. When you have variables in it. But idea is the same. Simplify the numerator and the denominator. And when I say simplify, add and subtract these. Okay, so in this case I need to add 4 over x plus 2 plus 3x. So I'm going to treat that as a separate problem over here. Okay, I have 4 over x plus 2 plus 3 over x. Okay, I can't reduce it. I can't factor either of them. So really I'm just jumping right into, what am I multiplying? I'm having a hard time writing that plus symbol. What am I multiplying each by to get a common denominator? And it's kind of a miniature problem here. Okay, well, this x plus 2 is a quantity, even though it doesn't show parentheses. So I have an x here, and I have an x plus 2 up here. Well, down here I need the x plus 2. Okay, and up here I need the x. Now, I can't say, well, I already have an x here, because this thing is a package deal. This x plus 2 is different x. If I said x is 5, that makes this 7. Okay, that's not the same. Right, if this is 3, that makes that 5. Okay, so I have x here, I need x plus 2. I have x plus 2 here, I need an x. Okay, so So that's going to give me a common denominator of x times x plus 2. And I need to multiply this by x plus 2. So I get 3x plus 6. Now notice I just did the quick distributive property. And I need to multiply this by x, and I get 4x. Add down, I get 7x's plus 6 over x times x plus 2. So now my new problem, this is that, right? So I have the numerator, 6 over x plus 2, plus the denominator, 7x plus 6, it's not plus, excuse me, divided by 7x plus 6 over x times x plus 2. All right, well that problem, switch up the color here, we're going to rewrite as 6 over x plus 2 divided by 7x plus 6 over x times x plus 2. And remember, we don't divide, we multiply by the reciprocal. So it's 6 over x plus 2 times x plus 2 over 7x plus 6. And these cancel. So I'm left with 6x and 7x plus 6. And remember, I didn't need a common denominator there because I'm multiplying. And you should always try to factor, but I can't factor the bottom into anything, so I am now done. All right, that's all I got for you. Good luck.